video, we're going to be talking about factoring special cases. So there's two different kinds of problems we're going to be talking about. The first one is called difference of squares. So you'll notice that it is this formula right here. We have a squared minus b squared, so you can either have a term or a variable or constant squared, minus b squared. Basically what you're looking for is two perfect squares. That factors into a plus b times a minus b. So we can do this two different ways. The first way I'd like to show you is more related to what we've been working with. So before, when we factored, we had something that looked like this: x squared plus some term in the middle and then a last term at the end. Because there's no term in the middle, you can think of it as 0 x's. So before, when I would factor this, I would say, okay, I need something that multiplies to negative 16 but needs to add to 0. So when I look at this, if I write out all the factors, I have 1 times 16, I have 2 times 8, and I have 4 times 4. I need negative 16, so I can make these negative, and then I could go over here, 16, 2 times 8, and 4 times 4. Or I could make these negative. So I have to choose one that's going to work. My only choice that's going to add to 0 is going to be negative 4 and 4. Notice negative 4 and 4, 4 and negative 4, it's the same option because just the order of the numbers, the way that it's written. So when I'm doing that, because there's no number out in front here, I would just write this out as my factors are x, one of my numbers, x plus 4, and the other number is x minus 4. And that would be my answer. Now, I'm actually going to write this down here. It would be x plus 4 times x minus 4. And this would be my final answer if I wanted to factor it that way. The other way that I can look at this is I can kind of follow what the formula says. The formula says I'm going to take my first term, that's a perfect square, and I'm going to match it up with here. And then I'm going to take my next one, we'll do in blue, b squared, which I'm going to match up with here. So I'm going to take each and I'm going to set it equal to each other. So I'm going to say that my a squared value is equal to x squared. And my b squared value is equal to 16. So I want to solve for a and b so that I can take those and plug them in the formula here. So to undo a squared, I'm going to square root. So the square root of a squared is a, and the square root of x squared is x. I'm going to do the same thing for the b. I'm going to square root b squared, and I'm going to square root 16. The square root of b squared is b, and the square root of 16 is 4. So now I'm going to take these values, wherever I have an a, wherever I have an a, I'm going to plug it in with an x here. And wherever I have a b, I'm going to plug it in with a 4. So my final answer would look like x plus 4 times x minus 4. Notice I get the same answer using two different ways. I don't really care which way you choose. You can literally choose any way you want. I'm partial to the way on the left. But if you want to be partial to the way on the right, that's totally fine. So I'm going to try the next example, and I'm going to try it with the way on the left. So I'm going to look at this. I remember that my formula says a squared minus b squared is equal to a plus b times a minus b. So I'm going to set my a squared equal to 9x squared. And I'm going to set my b squared equal to 25. So I get a squared is equal to 9x squared. And b squared is equal to 25. Okay, to undo a squared, I'm going to square root. So the square root of a squared is a. Now when I'm square rooting a term like this, the rules of square root says I'm going to break this up to the square root of 9 times the square root of x squared. The square root of 9 we know is 3, and the square root of x squared is x. So my a is equal to 3x. Now I need to solve for b. To undo a squared, I'm going to square root, and I'm going to square root on the other side. The square root of b squared is b, and the square root of 25 is 5. So now I'm going to plug these in my formula. Wherever I have an a, I'm going to replace it with a 3x. And wherever I have a b, I'm going to replace it with a 5 in my formula. So I end up with a final answer of 3x plus 5 times 3x minus 5. And that's my final answer. Let's try another one. Now I look at this and I might not say, well shoot, that doesn't really look like it's a perfect square to me, because these other ones, I know that 9 is a perfect, I know that 9 is a perfect square, I know that x squared is a perfect square, I know that 25 is a perfect square. And for those of you that are having a hard time remembering your perfect squares, it's these numbers. Let's make a list. I'm just going to write perfect square. We got 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. We can go a little higher. 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, 15 squared is 225. I think that's good for now. So those are examples of perfect squares. Those are the numbers that I'm going to be looking for to say, oh yeah, this is something that I'm going to use as my difference of squares, because I'm looking for perfect squares. But the other thing that you want to remember is maybe there's a GCF. So that's the thing I want to look for first. Is there a number that goes into both 8 and 98? So let's try it. Let's try the number 2. Remember, we want to try the biggest number possible. So let's start with 2 and see what number goes into. So 2 goes into 8. So if I took out a 2, that would give me 4x squared. And if I took out a 2, I factored it out, that would give me 49y squared. Is there a number that goes into both 4 and 49? Nope, because 4 and 49, I happen to notice that they're both perfect squares, but there's also no number that goes into both 4 and 49. So I'm going to, once my GCF is factored out, I'm going to take this on the same consideration. I'm going to let my a squared equal 4x squared. And I'm going to let my b squared equal 49y squared. So I'm going to square root both sides over here. So I get a is equal to, again, this is the square root of 4 times the square root of x squared, or 2x. And I'm going to square root both sides on this side to solve for b. So I get b is equal to the square root of 49 times the square root of y squared. The square root of 49 is 7, and the square root of y squared is y. So my b value is equal to this. So I plug it in my equation. Now remember, this 2 is my GCF. It just comes along for the ride. So it's like a tag along. You just bring it down. Follow along with everything else. So this becomes 2x plus 7y times 2x minus 7y. And that's my final answer. Okay. The next type of special factoring is called a perfect square trinomial. So perfect square trinomial looks like this. This is the formula. It's saying I have some sort of a squared plus 2ab plus b squared factors into a plus b times a plus b, which is really the same as a plus b squared. Or you could have it as subtraction. A squared minus 2ab plus b squared is equal to a minus b times a minus b. That's how it factors, which really factors into a minus b squared. So I have a couple examples for you. Again, we can set this up two different ways. We can set this up the way that we factored all of our other quadratics that looked like this. So I wanted to look at this and I say I want to multiply to 25 and I want to add to 10. So what multiplies to positive 25? Well, we got 1 times 25 and we got 5 times 5. We have a negative 1 times a negative 25 and a negative 5 times a negative 5. I want to add to positive 10, so it's going to be this guy right here. So if I were to factor this out, this would become x plus 5. Oops, I'm going to write it actually down here. This would be x plus 5 times x plus 5. But because they're the same thing, and actually we simplify it and we can just say x plus 5 squared. This is my final answer when I'm factoring this. Or I can look and use the formula. So again, I'm going to look in, I want to solve for my a squared and my b squared. So I'm going to take this value and I'm going to set it equal to my a squared. And I'm going to take this value and I'm going to set it equal to my b squared. So if I get a squared is equal to x squared, and I get b squared is equal to 25. I'm going to solve each one of these. Again, I square root to cancel out a squared. So I get my a value is equal to x. And I square root to cancel out a squared, and I get my b value is equal to 5. Now, the formula said a squared plus 2ab plus b squared. So I have to figure out if this middle term, 2 times a times b, is equal to 10x. So what's 2 times a, that's x, times b, which is 5. If I multiply all this together, 2 times x times 5, that indeed gives me 10x. So that means I can just use my formula. My formula says this is going to be equal to x plus 5 times x plus 5, or x plus 5 squared. Notice I get the same answer. It doesn't matter which way I do it. So depending on how you feel more comfortable, you can use the formula. You can use this like shortcut formula, perfect square trinomial. Or you can just factor the way that we've been factoring. Figure out what I need to multiply it by and what I need to add to. So let's try another one that's a little bit more difficult. We'll go ahead and we'll use the formula for this guy. So I'm going to take my a squared value and set it equal to 9x squared. I'm going to take my b squared value and I'm going to set it equal to 16. I'm going to square root both sides. So I get a is equal to the square root of 9 times the square root of x squared, or 3x. If I square root both sides over here, I get b is equal to 4. So let's check. My formula says it needs to be 2 times a times b to get the middle. So 2 times a is 3x and b is 4. 2 times 3 is 6. 6 times 4 is equal to 24, and then I have the x. So this matches this, which means I can use my formula to write my final answer, and that would be 3x plus 4 times 3x plus 4, which is 3x plus 4 squared. Final answer.